Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, we will deep dive into a full stack observability platform that is developed on the revolutionary eBPF technology, that is groundcover. If you are not aware what is eBPF, don't worry, we will also cover that in this video. So we will learn what is groundcover, how groundcover is addressing three major challenges with traditional observability platforms such as New Relic, Datadog, or others. We will learn how groundcover implements logging, metrics, tracing all at one place. And they also have a very cool feature that is groundcover playground. We will also explore their playground and finally learn how to set up, install, and configure groundcover with our Kubernetes clusters. So it's going to be very informative video. Stay tuned and watch this video till the end. Before we get started, I would like to tell you all, I have recently done a podcast with the CEO of Groundcover. If you are interested learning more about observability, learning about eBPF, how eBPF is revolutionizing this space, I would highly recommend to watch the podcast after watching this video tutorial. I will share that link in the description as well. Okay, now let's get straight into the point and learn what is ground cover, what are the three major challenges it is addressing. As I explained earlier, ground cover is a full stack observability platform. That means it can implement logging, metrics, tracing, alerting, dashboards all at one place. So if you are a DevOps engineer or site reliability engineer, it's a very good news because you don't have to use multiple tools to set up your observability stack. You can just use ground cover and it can be used as a complete observability platform for your organization. Now the big question is, but Abhishek, why? Why a new observability platform? There are number of tools in the market that is solving observability. So why should we go with ground cover? There are three major challenges. Over the years, when I worked with different observability platforms, I came across three major challenges, and fortunately, ground cover is solving these challenges. The first one is adaptability. If you look at any traditional observability platform, let's say Datadog or New Relic, to get your applications ready with these platforms, your developers have to go through costly coding changes, or they have to go through multiple development cycles, make changes to the application, and only then the applications are ready for the observability platform. So if you have a traditional application, a legacy application, and this application has multiple services, for your developers to get these services ready with these observability platforms, it takes multiple development cycles. And this is a concern for the organization. They have to spend a lot of time and money. Whereas ground cover use eBPF sensors. What does that mean? So eBPF is a revolutionary technology that allows you to run programs at Linux kernel level. So you can typically extend the capabilities of your Linux kernel. Let me give an example. Let's say you have a Kubernetes cluster with multiple nodes. Using eBPF, you can run custom programs at the Linux kernel level of each node of your Kubernetes cluster. And because transactions typically happen through the Linux kernel, every request that you send to your applications go through the Linux kernel. So the eBPF sensors that are developed by the ground cover can extract the information from the kernel. It can be the logging information, it can be the traces, it can be the HTTP requests. So these sensors can collect the information directly from the Linux kernel, which makes less effort for your developers. So your developers does not have to make significant changes to the application or does not have to go through multiple development cycles. So using eBPF, ground cover makes your application ready for observability. So this is one major advantage that you get if you switch to ground cover or if you start observability with ground cover. Now the second challenge, which is very important, is costing. Costing is a very important factor for every organization. And the problem with traditional observability platforms, again, it can be Datadog or New Relic, they charge you depending upon the amount of data that you are collecting. Let's say you have your applications which are logging a lot. If they have huge amount of info logs, debug logs. So these observability platforms, depending upon the amount of logs, they charge you. Now this becomes a bottleneck for the organizations. And what a lot of companies do is they don't set up observability at the lower environments, because setting up observability at the lower environments is charging them a lot. So they directly set up observability, a very good observability at the production level. Now the issue with this, you understand issues with your applications because you have set up observability at the production level, but it's too late. You're catching issues in the production. Whereas if the costing was less, companies would also set up observability at the lower environments, dev, staging, pre-production. This is where ground cover shines. So what ground cover does, they don't charge you depending upon amount of data, but they charge you on the nodes of your Kubernetes clusters. So this is very, very important again, because if you have observability at the lower environments, you can shift observability left. That is, you can start finding issues right from your development cycles. You can identify issues during the development. You can identify issues in the unit environment or staging environment. So you can avoid issues at the production level. So ground cover reduces the costing by approximately 80 to 85%. So this will help you set up observability at the lower environments and catch issues in the initial stages. So this is second advantage that you get if you switch to ground cover. Now, finally, the third one, and which is important for organizations, that is security. In 2024, we don't have to talk why and how security is important. A problem with few observability platforms is that they collect all these information. It can be logs, like the plain logs, JSON log, or the Nginx logs, or it can be some metrics or traces. They collect all this information and they store this information on their cloud platforms or on their cloud servers. Now, if you are in banking sector, financial sector, or any critical sectors, you cannot afford to do that. You cannot allow any organization to store important information of your applications. Again, this becomes a bottleneck because security is very important thing. So what ground cover does, they have a feature called in cloud, and using in cloud, you can actually store information on your cloud servers. So ground cover allows you to store your logs, metrics, traces, anything that is required for observability on your cloud servers. So this is a prime reason why again companies are looking at ground cover. So these are three major reasons which are challenges with the traditional observability stack, and ground cover is addressing these challenges using eBPF. Now that we learned about the challenges and we learned about ground cover, let's explore their platform. So this is the landing page of ground cover. You can also reach this page using link in the description or pinned comment. And through this page, you can typically navigate to any of their resources. Let's say you want to look at their official documentation. So you can click on the docs and check all the features that they have. Or let's say you want to look at the pricing model. So you can check out the pricing model. But what's most important that they have here is a feature called Playground. So Playground is basically like a demo environment or sandbox environment that they have set up for you. So this demo environment is set up just like a real environment with multi-node Kubernetes cluster and multiple pods deployed in it. So you can get a feel of ground cover, or you can get used to ground cover with this Playground environment. A lot of times you don't want to try out a new tool or a concept on your Kubernetes stack. So before you do that, you can actually start with the Playground environment. We will do both. We will explore the Playground, that is ground cover with a demo environment. And after that, I will also show you how to create an account and set up ground cover with your Kubernetes clusters. Let's start with the Playground first. So if you look at the ground cover environment here, you have infrastructure tab, which is basically for the infrastructure monitoring. So it gives you complete details about your infrastructure, that is the nodes of your Kubernetes cluster, what is the CPU utilization, memory utilization, disk utilization. Along with that, you can also see the running pods, deployments, daemon sets, replicas, jobs, cron jobs, and config maps. So you can also use it as your Kubernetes dashboard instead of, if you're not very comfortable with the CLI, you can also take a look at your resources from here. So it also helps you with infrastructure monitoring. Now, if we move to the actual three pillars of observability, that is logging, metrics, and tracing. Let's start with logging. So ground cover, as I told you, aggregates all the logs through their eBPF sensor. If you want to understand more about it, you can go to the docs, you can click on the log management, where complete details about this is provided. So they have a eBPF sensor called Alligator, and this runs as daemon set on the Kubernetes cluster. So when you install and configure ground cover, this is run out of the box as daemon set on your Kubernetes cluster. You can also check that if you go back to the infrastructure tab, and if you click on the daemon set, so you can see this is the one, Alligator. It is running as daemon set. That means it runs on each node of your Kubernetes cluster. So this is how it is aggregating all the logs from all the pods of your Kubernetes cluster, irrespective of the namespace. And once it collects all the logs, what it does is it forwards the logs to a connector called as OTel collector. And from the OTel collector, these logs are stored in the ClickHouse database. So this is just for your understanding how the architecture works internally. And this ClickHouse database has all the logs of all the pods of your Kubernetes cluster. This log explorer that you see here, basically when you execute a query, let's say I want to filter out only the error logs, right? So once you execute this query is executed against the ClickHouse database. And you can see all the error logs across all the pods, all the namespaces of your Kubernetes cluster. So this will help you debug and troubleshoot. You can use log management. And you have other features as well, like you can check the logs for last 30 minutes or last 48 hours, or you can apply your custom time range. Now, if you move to the next one, that is monitoring. So monitoring has both metrics as well as alerting. So what you can do with the ground cover platform is you can set up some monitors and you can also fire alerts. For example, in the Playground, there is an alert that is set up, which says if the pod memory usage is greater than 85% in the last 30 minutes, then you need to fire this alert. The query for the alert is also provided here. Let's say you want to set up same query on your Kubernetes cluster. you can copy this query and you can set up a new alert. Similarly, you can also use these options like what categories that you want. Do you want the storage category, resource, infrastructure, or API? You also have option of selecting the cluster. So ground cover is not only for one cluster. If you have multiple clusters, you can select the clusters from here. Right now it's playground, so they have this option. But when you install your own cluster, you can also see the name of the cluster. Perfect. So you can typically create metrics and you can also fire alerts. There is also a issues tab where you can look at the issue, and there is also dashboard section, because typically when you set up observability for your organization, you don't only want to have the metrics, but you also want to create some dashboards. For example, you might want to use Grafana dashboard and integrate this dashboard with the Prometheus data source. So this can be done with ground cover. It has Grafana inbuilt out of the box. You don't have to install anything. You can just create your own dashboard and you can use this dashboard. For example, there are some dashboards that are set up here. The network usage dashboard. So just like how Grafana works, you can see the same thing here on the ground cover platform as well, because it is set up with inbuilt Grafana. Now, if you move to the next one, that is tracing. So dynamic tracing is very important. Let's say there is some issue with your application, or one of your service is not responding, or you see latency issues with your application. How do you identify that? Ground cover specially shines in the dynamic tracing, at least what I have used it, because the eBPF sensor that they also have eBPF sensor for tracing. If you look at the application performance management and go to the tracing, you can read about their eBPF traces. So their proprietary sensor, what it does is it reads the transactions, or it gets the information of your HTTP request or the latency information from the Linux kernel level. And Linux kernel level can give you the most accurate information. So that is how you can get a perfect tracing and latency information of your application. So you can see the P50 latency as well as P95 latency. You can extract that information of your application. You can look at the errors, or you can look at the number of requests for your application. What you can do is you can also do that for a specific pod or the entire cluster, or you can only filter out a specific protocol as well. Like let's say I only want to look at the HTTP requests. So you can see all the HTTP requests along with the status codes that are incoming to your applications or pods on the Kubernetes cluster. What is the time taken for it? What is the response of it? If there are any errors, you can calculate. You can see the P95 latency, everything from the tracing dashboard. Above all of this, like let's say you want more information about your Kubernetes cluster stack, there is also a network map. So this network map provides you clear insight of the complete architecture that you have. Like how is the HTTP traffic flowing? What components are using this HTTP traffic, or how the HTTP traffic is flowing through your environment. You can record and see the gRPC transactions. And finally, you can also see how this entire information is collected by the ground cover alligator, which is a eBPF sensor. So all this information can be taken from the ground cover platform. So this is how the network map also helps you. So these are different features that they have. Along with that, you can also look at your Kubernetes events. Let's say you don't have a Kubernetes dashboard for your Kubernetes cluster. You can use this dashboard for looking at the events of your Kubernetes cluster. Now let's take a look at how to set up ground cover with our Kubernetes cluster, right? Of course, it is exactly the same. The only difference is that here you see the nodes of the demo environment, whereas once you set up ground cover with your Kubernetes cluster, you would see this, and the information like logging, tracing would change accordingly. But you would not see any change in the platform that you're seeing here. So to set up ground cover, firstly, go to the login page and just sign in with your Google account or the SSO, whatever you have. I have signed in with my Google account. You can see here. And immediately, as soon as you sign in, you get a shell script or you get a shell command that can set up ground cover with your cluster. So I have a Kubernetes cluster already. Let me pull my terminal. So this is my Kubernetes cluster that I have. If I just do kubectl get nodes, so it is a EKS Kubernetes cluster, and this Kubernetes cluster is set up with 2 nodes. And right now there is nothing in this. I have not set up any observability, no logging, no tracing, no metrics. Let's see how to integrate. So first, copy the command, copy, and go back to the terminal. Just execute it here. And ground cover will start installing its CLI, the token that is required. And most importantly, it will also set up some persistent volume claims. So let me just say yes. So you can see it is installing the ground cover Helm release. Make sure, one thing to note, if you are using AWS, that is EKS, so you should have these PVCs attached with the persistent volume. For that, what you need to do is you need to make sure, like, do kubectl get storage class. So the default storage class is GP2, and even here it is using the persistent volumes with, the persistent volume claim with GP2. So what you need to do is make sure you have the EBS driver running on your Kubernetes cluster. So if you do kubectl get pods in all the namespaces, you should see this particular CSI driver, EBS CSI controller. Because if you don't have this, ground cover cannot get the persistent volumes that is required. All the information that it stores are stored in the persistent volumes. So make sure if you are installing ground cover on the EKS cluster, you should have the EBS CSI driver installed. Of course, it is not mandatory to use EBS only. You can use EFS or you can use FSX, but the default out of the box option is EBS. So that's why I was telling you to make sure EBS is installed. Okay, so it says everything is fine. Let's go back to the platform and see. So it will take just a couple of minutes for the changes to reflect. Make sure once you install ground cover, you wait approximately for 4 to 5 minutes, because it has to get all the information from your Linux kernel of multiple nodes of your Kubernetes cluster. Perfect. Now it says, congratulations, you're all set up. So let's say, let's go. And let's see if it is able to identify our infrastructure at the first level. So it has identified one node, and it will take little more time for identifying the second node. And make sure only once you see both of the nodes, then start using the platform, because only then you can get the complete details about your system. It typically takes 2 to 3 minutes for getting all the information about your infrastructure. Meanwhile, let's see if we have all the other things in place. I missed to explain the API catalog while I was talking about the demo environment or playground. So API catalog again gives you information of different APIs that you have on your cluster. You can pick up one API, or let's say you can pick up one service and monitor the status of that particular service. Let's say I want to look at this particular API /health of core DNS. So you can get all the information like the requests that are coming to core DNS, when the requests have come to core DNS, on what API, what is the status code. Again, you can also filter out the event types. The core DNS API, I think it is of type HTTP only. So you only see the event type of HTTP. If you have gRPC or HTTP2, then you would see another option here called gRPC. Perfect. So we can also look at the logs. By default, there will be a lot of logs on your Kubernetes cluster without even making a single change to the pods. Here we have aggregated all the logs, whether it can be the EBS CSI driver or the kube proxy. We can again use the same filter. Let's search for log level and let's look at error log. Right now, you will not find anything because there are no error logs in the pods that we have deployed. Kubernetes events. Okay, these are the different events. Initially, the ground cover pods were unhealthy because of the probe failure, but right now they are all good. Similarly, you can use PromQL queries to extract metrics of the applications or the metrics that you have on this Kubernetes cluster and set up any alerts that are required. So you can use PromQL for that. And you can use the inbuilt dashboards like the Grafana dashboards that are available out of the box. Just like we saw the network dashboard when we were using the playground. Now we can take a look at any other dashboard. For example, let's use the distributed tracing. And it provides you different applications, how the traces are that for that particular application. For example, you have the EBS CSI controller. You can get the information about it. So meanwhile, let's go back to the infrastructure. Yes, both the nodes are being monitored. You can see the CPU utilization, memory, and disk utilization. And if you go to the daemon sets, so clearly you have the alligator that is running, which is a daemon set eBPF sensor of ground cover. So this is how you integrate ground cover with your Kubernetes cluster